The mean of this distribution is 500, and the standard deviation is 100. So now to find this probability, we have to enter this into the calculator. So here's where part C of that function comes into play. So sometimes the starting or ending value may be infinity or a negative infinity. So for the TI-83, the way that it represents infinity is with this statement, 1E99. So what that means, we've seen this at least once before, is that means you're taking 1 times 10 to the 99th power. In other words, you have a 1 with 99 zeros after it. That's not infinity, it's just a really big number. Okay. So I give you some instructions to enter the E, but my suggestion is just use a really big number. You don't have to have 99 zeros, just put in a bunch of zeros. If you wanted a negative infinity though, then you'd have to put in a very negative number. Okay. So this brings up something that I wanted to mention. If you want to input a negative number, say, I don't know, -5, you do not press -5. That's not a negative sign, that's a subtraction sign. If you want to indicate a negative number, you need the negative sign next to the decimal. So if you wanted negative infinity, you could say -1 bajillion. Just press the 0 a bunch of times, and that's close enough. That's a really negative number. If you wanted positive infinity, then you would just say +1 bajillion. Just press 0 a whole bunch of times. Another really big number, close enough to infinity to work. Okay? Either way you do it's fine. You can use the technical notation 1E99 or just use really big numbers. So we want, again, normal CDF. Starting at negative infinity. So we'll press second vars to get to the distributions. We want normal CDF. So now we want to indicate a negative infinity. So I want -1 bajillion, comma, then I'm ending at 350, comma, my mean is 500, comma, standard deviation was 100. Press enter, and there you go. So 0.067, we'll call it. And that's the same as 6.7%. Okay, so that's the answer, and what this means is a math SAT score of 350 is the 6.7th percentile. Not a very good score. If you got a 350, you did better than about 7% of people. So 93% of people roughly did better than you. Not very good. Okay. Next question, to be at the 75th percentile, that's pretty good. What do you need to score? Okay. So we can just roughly sketch out this distribution again. We don't have to be very specific because we've already done it above. So there's the mean of 500. We'll just indicate where the standard deviations fall. We want to be at the 75th percentile. So we know from the last example that the 98th percentile is somewhere up here. The 75th, is probably somewhere in here, if I had to guess. But we don't know what that point is. But what we do know is that at or below that point is 75% of the distribution. So how do we find this score? Hopefully, you said, you'll use inverse normal because we're given a probability. We're not finding a probability, so we cannot use normal CDF. We're finding a score, so we have to use inverse normal. So we're going to use inverse normal. Again, the first thing we tell it is how much of the distribution is to the left of the point we want. Percentiles are nice because they always tell us what's to the left. So we have 0.75, the mean is 500, the standard deviation is 100. So 0.75, 500, comma 100. So that would be a score of 567. So my guess was off a little bit. 567.4. So I put it above 600. So this first line was 600. Actually, the point would be here. But that's okay. The picture doesn't have to be perfect. The point was we knew that it was somewhere above the mean. So that means we expected this score to be above 500, and we got 567. So it lives where we expected it to be. So then one more, let's estimate the 10th percentile. So 567 is the 75th percentile, 350 is the 6.7th percentile. It should be somewhere between 350 and 567. And we can even do a little bit better because we know that 500 is the median as well as the mean, which means it's also the 50th percentile. So our score should be between 350 and 500, more towards the 350. So there's the distribution. The 10th percentile is a low score. So maybe it's somewhere here. I don't know. We don't know what it is, but we know that at or below that point is 10% of the distribution. Okay, so just like before, we're finding a score. We have a probability, so we will use inverse normal. We have 10% to the left, 0.10, same mean, same standard deviation. We're not changing the distribution. So you should end up entering something like this, 0.1 or 0.10, doesn't matter, 500, 100, and then you should get 371.8. So again, right where we thought it would be, between 350 and 500, but more towards the 350. And the answer we get is 371. So it matches what we expected, so that's nice. So a math SAT score of 371.8, if you want to do some more decimals, that's fine, is the 10th percentile. Okay, not too bad. With the normal problems, again, it's kind of obvious for now that you're dealing with a normal distribution because I tell you something's approximately normal. Kind of the tricky part is figuring out what do you want. So the first step is, do you want a probability or do you want a score or a height or a weight? Because that's telling you which calculator function will you use. Will you use normal CDF or inverse normal? Then it comes down to the other pieces. Well, where is the region that you want? Where might the score you want fall? How much of the distribution is to the left of the score you want? But at least kind of getting on the right track I think is a little bit easier in these types of problems. Again, it just takes practice. So I think one more page. There is a last page about combinations and stuff. I called it an addendum. I'm not going to go through that. That's just for you. So all that we have left is this example 14, and we're done with chapter 6 finally. So we're going to use the calculator. So if you look across these statements, it says find the probability that z is less than 0.17. That doesn't seem to be enough information, but in fact it is. So anytime you see z, that's common notation that you're dealing with z-scores. And that means you're working with the standard normal distribution. So we have a normal distribution with a mean of 0 and a standard deviation of 1. So in this first example, find the probability that z, so that's just a z-score, is less than 0.17. So let's sketch that out. We have a normal distribution. These are for z-scores. And this one's pretty easy to draw. The mean is 0, and the standard deviation is 1. So we go up 1, 2, 3. We go down -1, -2, -3. And we want to be less than 0.17. So there's 0.17. We want to be less. Okay. So we don't really need the empirical rule here. We can just use what we know about symmetric distributions. So we know that 0 is the mean as well as the median. So half of the z-scores will be below 0, half will be above. Our region is just a little bit more than half. So this probability should be a little bit more than 50%. So how do we actually find this probability? Well, we have to figure out which function to use. We have a normal distribution. We're finding a probability, so we're going to use normal CDF. And we'll use that for most of the following examples. Okay. So again, sometimes this is tricky at first. Where does this region start? It does not start at -3 because this normal curve goes forever. So we're starting at -infinity. We are ending at 0.17. We have a mean of 0 and a standard deviation of 1. Okay. So let's see what that looks like. So we need a, again, really negative number, so we'll use this negative sign. -1 with a bunch of zeros, that's plenty. Up to 0.17, mean of 0, standard deviation of 1. And we thought we'd get something a little more than 50%, and we get about 57%, so 0.567. So a cautionary note, or maybe something you can use to your advantage, up to you. What would happen if you leave off the mean and the standard deviation from these functions? Well, as you can see, in this case, you'll get the same answer. So what that means is, if you don't input the mean and the standard deviation, your calculator will assume that it's a mean of 0 and a standard deviation of 1. So if you leave those off, and your mean is not 0 and your standard deviation is not 1, this number will be incorrect. So just get into the habit of always entering the mean and standard deviation, even if it is 0 and 1. Okay? So a couple more. What's the probability that a z-score will be greater than or equal to -2.17? So sketch that out. We want to be above -2.17. So I didn't fill out the 1s, 2s, and 3s. It's the same picture. So So we're just a little bit past -2, and we want to be greater than or equal to. So we want to be above this point. We want to be at least -2. So this is a lot of the distribution. So we've certainly included one standard deviation, 68. We've included two standard deviations, 95, plus some. So our solution should be more than 95% according to the empirical rule. Again, we're finding a probability from a normal distribution, so we will use normal CDF. So this area starts at -2.17. Where does it end? Not at +3, but at positive infinity. Still the mean of 0, still the standard deviation of 1. Okay, so we're starting at negative, this button, 2.17, going to a very positive number,